All right, let's jump right into this explainer. Today, we're unpacking a really groundbreaking framework from NVIDIA Labs that is basically fundamentally changing the evolution of AI agents. For the longest time, building advanced AI systems, it kind of felt like stitching together this Frankenstein's monster, right? Just disjointed prompts, massive JSON schemas, super fragile orchestrators. But today, we're actually witnessing a cinematic shift toward elegant native code. We're talking about NVIDIA Labs Object-Oriented Agents, or NOA for short. And this isn't just about, making coding a little easier. It's a complete rethink of how we author intelligent systems from the ground up. And spoiler alert, it also brings some major urgency to the need for self-hosted sandbox environments, like AgentENV, to keep these advanced action-taking models safely contained.
So here's our roadmap for today. First, we'll meet NVIDIA O agents. Then explore the Pythonic paradigm shift and look at execution as code as action. After that, we'll tackle the sandboxing imperative and wrap things up with agnostic models and tracing.
All right, Section 1. Meet NVIDIA OO agents, rethinking agent frameworks.
Let's start with the absolute core problem developers are facing today. If you've built AI agents recently, you definitely know this pain. Traditional frameworks are a mess. You've got one file for system prompts, a totally separate layer for tool definitions, which, let's be real, is usually just heavily nested JSON, and then another layer for the workflow. It's completely scattered. NOA, on the other hand, proposes a really elegant model-agnostic alternative. It unifies all of those scattered concepts into a single Python class, so it's treating your agent not as some magical, mysterious entity, but just as standard software.
Actually, the crucial point here is summarized perfectly right in their documentation. The agent is a Python object. Now, I know that sounds almost too simple, right? But by stripping away all those bespoke, clunky abstractions, NVIDIA Labs is basically letting developers express state, capabilities, interfaces, and prompts entirely within the boundaries of familiar native Python.
Moving on to Section 2, the Pythonic paradigm shift, mapping concepts.
So this brings us to a massive paradigm shift in how we actually author these AI systems. I mean, if the agent is just a standard object, how on earth do we tell the LLM what to do? Well, it is wild how seamlessly standard Python concepts translate into agentic concepts here. Your normal class fields, they maintain the agent's state. The methods you write act as its capabilities or tools. Your everyday Python docstrings directly become the LLM prompts. And those type annotations you're already writing, they act as strict contracts and schemas. You literally never have to write separate tool schema definitions again, because the Python class itself is the interface. It's brilliant.
Section 3. Execution. Code as action.
Okay, but how does this elegant structure actually do anything dynamic? A standard Python method is inherently deterministic, right? Well, the AI comes into play with 3 simple dots. Just an ellipsis. By placing an ellipsis in a method's body, you're signaling to NOA that, hey, this isn't deterministic Python. Instead, this method is going to be implemented at runtime by an LLM-driven strategy. It becomes a dynamic agentic loop. If you write out a real body, it stays deterministic. But if you leave the ellipsis, the AI takes the wheel, acting entirely based on the method signature and the docstring prompt.
Let's look under the hood at what this idea of code as action truly means. Instead of the model just spitting out text or rigid JSON arrays to trigger some external tool, the model actually takes action by writing real, executable Python in a Jupyter-style REPL. And because it's executing inside the object's context, it has native access to self. It can call helper methods or access the state directly. It can use imports. It even uses typed input-output with automatic retries if it happens to hallucinate. This is a completely agent-oriented workflow, totally designed for the real world of testing and version control.
Which brings us to Section 4, the sandboxing imperative, securing the environment.
Now, when an LLM is writing real executable Python, the stakes are incredibly high. This whole evolution necessitates a pretty harsh reality check on system architecture. We have to clearly distinguish between a simple defense-in-depth guardrail and a true containment boundary. NLaw does validate generated code using abstract syntax tree checks and module denial lists before it actually executes. But listen, these are just defense-in-depth measures. They're meant to catch early, innocent mistakes. They are absolutely not a containment boundary designed to stop an LLM that is actively writing code to escape its confines. In-process validators alone simply cannot protect your host system.
And why is that? Well, because a static checker over Python simply cannot guarantee safety against an intelligent model. Think about what basic Python can do. Generated code could use the standard open function to maliciously access private data, delete files, or completely mess up your environments. It could use importlib to load modules straight from a hidden path. It can use reflection to reach into the rest of the system. You're literally giving an AI the ability to author and run code dynamically.
Therefore, the documentation explicitly warns that you must always run agents executing generated code inside an OS-level sandbox. The true containment boundary has to be isolation at the operating system level. You absolutely need a robust, self-hosted sandbox environment, something like AgentENV, NVIDIA OpenShell, or a strictly isolated virtual machine to ensure your primary file system is completely shielded. Building advanced, cinematic AI experiences requires accepting a hard truth. Code as action is inherently dangerous if you leave it uncontrolled.
All right, Section 5, Agnostic Models and Tracing. Quick start.
So with our strict safety guardrails firmly established, how do we actually spin up a project and see all of this in action? Well, the workflow is wonderfully straightforward, and it leans heavily into familiar developer habits rather than forcing you to learn some brand new proprietary pipeline. You just initialize your project with VU or pip, and then follow 3 really simple steps. 1. Choose a model registry. 2. Create your Python object extending the NOOA agent class. And 3. Trace its execution.
Honestly, one of the best parts about this entire framework is that NOOA is completely model agnostic. By utilizing light LLM registries under the hood, you are never locked into a single provider. You can plug in Anthropic's Claude, OpenAI's GPT models, or seamlessly swap over to local variants like a QN model running through a Llama or VLLM with literally zero friction. It just takes one line of code to get the LLM client and pass it straight to your object.
Furthermore, the moment you run your code, you aren't left in the dark. Every single LLM call, every line of executed REPL code, and every method invocation is automatically traced by default. It perfectly preserves the parent-child spans of your orchestrators and helpers. By simply running NOOA start dev in your command line, all of this is instantly viewable in your browser via a local dev server. So, you maintain full 100% visibility into exactly what your object is thinking, generating, and executing.
I really hope this explainer helped you grasp the immense power and honestly the critical responsibilities of object-oriented agents. We are moving far away from those messy workflows and stepping right into an era where native code rules. But this evolution brings a pretty heavy question that you're going to have to answer for your own projects. Think about it. If the future of AI is simply standard Python objects dynamically writing and executing their own logic, is your current infrastructure sandboxed enough to survive code as action? Something to chew on. Until next time, keep learning, keep building, and stay curious.